Okay, so I chose to do my project on freezing point depression, and this is one of the colligative properties that we learned about. And colligative property is, it more depends on the concentration of like the solute being dissolved rather than its actual chemical identity. So it's more about how much you have within the solvent that will cause it to change. So with freezing point depression, we learned in class how the freezing point is actually lower for a solution than it is for a pure solvent. So that basically just means that the freezing point decreases when a solution is present compared to when it's just pure water. And we will be able to see that as... So I have my tray of ice cubes. I am going to put a full half teaspoon on this end. So I've split it down the middle. These are going to have nothing on them. This side will have the solute on them. So I'm going to put salt on here, here, and here. I'm going to do probably the full half teaspoon on these, maybe a quarter teaspoon on these, and then just a little bit on these, just so we can kind of see variation, and we'll watch to see which side melts more. Okay, we are about 3 minutes in, and you can see that there is already some puddling of water right here. I don't know if I can okay, there you go, you can see that. And also, just even on the one that didn't have very much, I just sprinkled a little bit of salt on there. This ice cube was a little bit bigger, so it also is melting, but not as much as this one that had the half teaspoon on it, but was a bit smaller of ice cube. So, little pool there, and then on the other side, we have no water yet. Okay, it's now been about 12 minutes, so we're going to just check back in on this. You can see that a lot of the salt on this front one has melted. There's kind of some clumping going on back here, but they have pulled away from the edges, and this one especially is really melting. Oops, might have just interfered with the experiment. I was trying to show you there is water underneath them. That one looks like it's just floating around. And then on this side, looks like the top is starting to get a little bit glazed over. Okay, we're at about 25 minutes now. This side without the solution is making a little bit of progress. You can see a little bit of water on the top, so a little bit of melting happening. And then on this side, this far ice cube is now lifted up. It's completely just sitting in a pool of water. This one is stuck to the sides, but there's a big pool of water on top of it. And then these two, or I guess these four that had less on them, are still melting just a little bit slower. Okay, we're at about 48 minutes. Oops, it's blurry. You can see that there's definitely some melting happening, a lot more melting with the side that doesn't have the salt on it, and then lots of melting here, it's kind of looks like crystally around here. The ice is kind of going up the side a little bit. I don't know if you can see that. Yeah, my pencil's making it worse. There we go. So lots of melting happening on the salt side, and this cube you can tell is really pulled away from the walls, and even these ones that had just a little bit of salt in them, I keep making it blurry, they are melting way more than the ones that did not have any at all. Okay, we are at 2 hours, 45 minutes. You can see that all these have melted, but these ones over here, well, not melted completely. These ones, this just has a little tiny ice cube left in it, and this one also. So those are almost completely melted. This one is a little bit smaller than this one just because it had more salt over here. And then these ones have also melted, but they still have pretty big sized ice cubes. So that's kind of the final result. Okay, so now that we have watched both of the experiments, the salt melting the ice, and then also using salt and a lot of it in big sea salt pieces, and putting that in with ice and then using that to make ice cream, I'm kind of going to go back and explain what is going on there and the chemistry behind it. So I have my notes here to help me. So in the textbook, it talked about how with melting, what's happening is the solute molecules are like dispersing between the solvent molecules, and so it's kind of getting in the way of those ice crystals forming. So it's basically like disrupting the ice crystal structure, and so that's why it's gonna be able to like help it melt. And it's not technically helping it melt or melting it. It's not doing the actual melting. It's just lowering the freezing point. So with that, in the experiment we saw it took almost 2 hours longer, I guess an hour and a half longer for it to melt, just on its own. And then the one that had the salt, it melted pretty quick. And then I was just looking this up and found some different articles on it, and when talking about melting and adding salt to it, it actually makes it colder, because it is lowering the freezing point of it, which is going to make it colder. And that is also causing the ice to melt faster because we have to be even colder to melt it, or I mean to freeze it. So it's going to be at not a higher temperature, but it'll be more easily melted, and it'll melt faster because it's absorbing heat from its surroundings. And the salt also makes the ice colder because the salt prevents melted water from freezing. So we know that melting is endothermic. And then, let's see, just some other key points about salt and ice. Like I said before, it's not actually melting the ice. It's appearing that the salt is melting the ice, but I found an article that says it's actually more accurate to say that it's lowering the freezing point, which we know, which is just causing the ice to melt at a lower temperature. And it's really about the concentration of how much solute you've added, and that's going back to like the idea of the colligative property. Okay, so then some common applications, we see it like on sidewalks or on roads to help the ice melt a little bit, and then also with making ice cream. So in the video you saw that I used a third cup for 3 cups of ice. So I used a third cup of those big sea salt chunks, and I put that in the ice, and that was in one bag. And then in my other bag, I had my cup of half and half. I had 2 tablespoons of sugar, and then I think it was like a teaspoon of vanilla to make vanilla ice cream. So I was kind of confused, like, once I put a bunch of salt in this ice, isn't it going to make the ice melt? And while it is kind of melting it, it's lowering the temperature. So we need to be able to have like super cold temperatures to make the ice cream, and you just kind of shake the bag around. It took about 7 minutes. So I was thinking, like, how does this make sense? Why do we use salt to melt ice on sidewalks, but then we also use it to make the ice colder so that we can make ice cream? So one article I found from McGill University in Canada, it says, in both of these cases, the answer is based on the fact that adding salt to an ice-water mixture in equilibrium lowers the freezing point of the equilibrium. So when you're just adding ice, like to the ice cream maker, or for me it was just into the bag, the ice absorbs heat from the surrounding and it starts melting. So it's gonna start increasing in temperature. It says that at 0 degrees Celsius, equilibrium is reached, and the temperature cannot go any lower. So this is not cold enough for making ice cream. But then we add salt, and the equilibrium will be reached and then kept at a lower temperature, which is what is required to make the ice cream. So when the salt comes into contact with the ice on like the road or something, some heat is released because of the solvation process, but this ice also, this melts the ice, yielding the ice-water equilibrium that we talked about before. So because of the presence of the salt, this mixture will refreeze at lower temperatures than 0 degrees Celsius. So that, in the case of the road, is going to help it not freeze, but in that process, it's also going to be lowering its temperature, making it colder, which is why we can use it to make ice cream. So overall, this was really fun for me to do and very entertaining and yummy. So I feel like hopefully it's beneficial to you guys so you can know how to make homemade ice cream with 3 ingredients. Okay, I guess 5 if you're including salt and ice, but basically 3 ingredients in 7 minutes. So very beneficial and very yummy. And yeah.